Due to its compact design, the Morgan press requires only a few square feet of shop space. Because of the inherent simplicity of the equipment, personnel with practical shop skills can easily be trained to operate it. To begin a molding cycle, a two-part mold, unmounted, is placed in the press centered on the lower table platen. Upon actuation by the operator, the table platen, which is the major moving part of the machine, moves upward to clamp the mold against the injection nozzle. Thermoplastic material heated to the proper melt temperature is injected under high pressure into the mold. After a short interval, 5 to 10 seconds, during which the plastic cools and solidifies in the mold, the injection pressure is released and the table is lowered. The mold can then be removed from the machine. The mold halves are separated, and the operator can remove the plastic part. The mold halves are then rejoined, ready for another shot. Electronic temperature controls are located in a cabinet mounted beside the press. These controls maintain selected temperatures in the two material melt zones. The upper portion of the press houses the injection system. In the side of the top casting, covered by a wire safety guard, is the material loading chute. Raw granules of thermoplastic material are loaded here and transferred down into the material melting cylinder. The action of the injection barrel piston can be seen through the loading chute. Injection pressures of up to 13,500 psi are possible. Surrounding the material melting cylinder and injection nozzle is the upper platen assembly, constructed of 1-inch tooling plate aluminum. This distributes clamp force loads over the entire mold surface and has mounting provisions for upper mold halves when used in semi-automatic operating mode. In semi-automatic operation, the mold halves remain attached to the upper and lower platens of the press. Ejector pins are designed into the mold and eject each plastic part at the end of the operating cycle. This mode is ideal for short production runs of as many as several thousand pieces. Returning to the basic components of the Morgan press, we have the clamping area, which is enclosed by a sliding wire guard, which must be in the lower guard position before the press can be actuated. 4 precision ground chrome stanchion posts align and support upper and lower components of the press. These provide a vertical track for positioning the clamp table. The heavy base casting provides a base for the toggle lock clamping mechanism, as well as housing lower control elements, including pneumatic valves and pressure regulators. The orange knobs operate the clamping system, while the black knobs regulate and control the injection function. The powerful air-driven toggle mechanism uses a locking over-center principle to provide solid clamp for the table platen. Positive opening and closing strokes are important features of this mechanism. Clamp forces of up to 20 tons maximum can be achieved. Mechanical adjustment of table height is accomplished with a table elevating spindle located on the right side of the table. This operation, similar to adjusting a pair of vice grip pliers, is necessary to obtain proper clamp force on the mold. To power the Morgan press, only two sources are needed: clean shop air and 120-volt electrical for controls and heating. This, along with its compact design, means a Morgan press can easily be shifted around various shop areas when and where it's needed. An optional preheat plate is available. It hastens first shot warm-up temperature and maintains mold temperatures for more consistent quality and cycle times. Optional precision temperature controllers are also available. Mounted on the left side of the press, these electronic solid-state devices provide plus or minus 1% accuracy over a temperature range from 0 to 800 degrees Fahrenheit. Three-mode digital set point and readout modules provide very accurate temperature regulation over both material heating zones. They are recommended for use with high-temperature thermoplastics and materials with narrow melt degradation temperature ranges. The major economic advantage of the Morgan press is utilization of low-cost tooling. In most cases, simple molds, often designed and fabricated in-house by the user, are all that is needed. This part is a prototype screw-in light sensor housing. Sturdy aluminum or mild steel molds can be fabricated on basic machine tools available in the average machine shop. This simple hand-operated milled mold was used to produce a plastic living hinge. Lathe turned out of round aluminum bar stock, this hand mold was used to produce a tubular housing with flange and O-ring groove. And here is an example of a low-volume prototype hand mold made by routine milling operations from aluminum bar stock. There's no requirement for a custom mold base or special mounting for this type of tooling. The part is a prototype cylinder housing for a door lock set. Here is a turned hand mold set for a prototype light sensor housing, a part of considerable detail and complexity. Where greater detail is required, as in this mold for a model slot car body, temporary tooling from epoxy, Kirkside, or other castable materials can be made from easily produced masters. A wide variety of ASTM test specimens can be produced by the Morgan press for material test and quality assurance groups. Semi-automatic tools, such as this two-cavity mold for tensile and impact test specimens, do require extra ejector and mounting provisions. However, this type of setup enables faster sample production.